Right, we have done a little bit of geometry, just a little bit, that you are into the two theorems that you're doing in grade 12. The first theorem is the one that you've got a triangle, and there's a line parallel to one of the sides. The abbreviation is line parallel to one of the sides of a triangle. We'll do what? We'll divide the other two sides proportionally. Now please remember, you were taught in grade 11, that you have 4 theorems to go prove. Right? You have 9, but you only prove 4 of them. Those 4 should be on 4 separate papers, and here comes number 5 and number 6, the next one as well, the proofs of your theorems. So if you're doing the proofs of your theorems, you have to have those 6 pages there, and you've got them written down like this. Prove the theorem that states that. Giving you the sketch, and there you go. Then you can copy that for yourself a few times so that you can all the time practice this. Because now you're going to mark this afterwards according to the memo and see, oh, I failed to look at this, this and that. Now this one is a tricky one to prove that. Now guys, you know this already from the previous work that we've done. You know basically what it says. If there's a line parallel, it will take these sides and divide them in the same proportional ratio. So ratio here is the same as the ratio there. That means that they are divided proportionally. So if they're in the same proportion, they're divided proportionally. Right. So if I have to prove that, this is what I'm trying to prove. AD over DB is the same as AE over EC. But now remember, all the time, we first did the sums, and then you say, but ma'am, I know this. Yes, you know it, but now we've got to prove it. The proof has always got a construction. All 4 of the ones in grade 11, these 2 coming in grade 12, all of them have a construction. The rule is, if you start off with your proof and there's no construction, 0. 0. Also, good news, if at least you know your constructions, you've always got 1 mark. Even if the rest of this proof is not right. You've always got 1 out of 5, 6 marks, definitely. So the proof is the following. Now before I get to the proof, I need to say a little few things. And that is that when I'm looking at the area of a triangle, it will always be half base times perpendicular lines. We also know half A, B, and C, don't we? Mm-hmm. It's not going to be applicable for the sum, but you've got to know your whole toolbox full of information. So if we want to do that, and the triangle looked like this, and this was the base, then no problem, the height would be there, perpendicular height, and then I'll give you some information on it. What did you do if a triangle looked like this, and this was the base? Your height then will be from the top point there to where? It's got to go straight down where there is no triangle. So you've got to extend and make it perpendicular. That would be your perpendicular height. Or in other words, if you wanted to say, if those are parallel to each other, that constantly would be the perpendicular height. Alright, so then perpendicular height. That's something that you need to know for what I'm starting to do there. There's another thing, pre-knowledge, that you've got to know before I start there. That if ever I work with the area of a triangle, and I'm looking at a triangle, 2 triangles on the same base. Because remember, the area is base and height. So obviously if I've got one triangle with the same bases as the other triangle, and their heights are the same, then their areas will be the same. The bases and the heights are the same, the areas will obviously be the same. So there is a theorem in grade 10 that they don't rarely use anymore. You don't even really touch it. That says that if you are in a triangle and you want to work out the area of 2 triangles, and the one's base is the same as the other one's base, I'm going to make it purple. Do you see the base being the same? Mm-hmm. The heights will be the same if they lie in between the same 2 parallel lines. Is that logical? Yes. Because then from there to there, the perpendicular height, and from there to there, the perpendicular height will stay the same, because that's like train tracks. They don't go like this. They've got to be the same distance all the time. So that would be my perpendicular height. So the rule there is, and we're going to use it in this proof, that these two areas of a triangle, if you want to say that one triangle is equal to the other triangle, the reason then for them being equal is they have the same base, same height. Actually, then we say the same two parallel lines. Because they're in between the same two lines, that makes them have the same height, making their areas the same. If the base is exactly the same, and the heights obviously is the same because it's between the same two parallel lines, because that's, are you with me here? Do you understand this?
Yes.
It's a theorem that says, if this happens, even if it's turned around, because that's going to happen now then, if it's in between the same two parallel lines, and I'm looking at this as a base, and there goes one triangle, and there goes another one, what's going to happen to these two green triangles' areas? They will be the same, because their bases are now the same, it's just a little bit lopsided, but the height would still be the same because of the parallel lines. What's the reason? Same base, same parallel lines. That's why their areas will be equal to each other. So this is the background that you need for this theorem. Now this is a very strange, unusual theorem, but when I start off with it, you are going to have to know that you're going to work with two triangles. Triangle ADE, then also triangle DEB. You see this coming. Then you're also going to have another one over there. Now guys, how were you just supposed to know this? No, you weren't. That's why you're getting taught it. That the way to prove this is to go and say area of triangle, this top purple one, ADE, you're going to put on top of the area of this bottom triangle. Now remember, there's always method to this madness. You're aiming for this. So in doing this triangle and this triangle, I'm getting to AD and D because those are going to be my bases. Are you following where we're going?
Yes, ma'am.
But how are you supposed to know how to do this? This is what I'm teaching you. So when you have to do this sum, this proof, that's what you're going to do. You're going to use ADE, the triangle, over this triangle to get to these bases.
Okay.
Are you with me?
Yes,
I'm going to
ma'am.
show you in advance where we're going. So that'll be triangle there. BDE, DBE, doesn't matter. Will be equal to. So I'm saying that you must know. If I take them and I look at their areas, what is the area of a triangle always?
Half the distance perpendicular height.
So now in those two triangles, the bases obviously I want them to be AD and BD. But now if I look at this triangle with my head like this, base, then where's the height? Should be coming from
Top going down.
top point E. So E should be going, let me do it in red. E should be going here perpendicularly, and the height can then be called H for height or whatever. I think in the textbook they also have it H. And then, okay, what is the height then for this triangle? If you remember what I just showed you here. Because if this is the base, where's the height coming from? Also from E, and it can't come perpendicular here because this is an obtuse angle. You'll have to extend it. So that will also be the height for this triangle with this base. Are you with me? Remember, I'm forcing this. Why can't I use the area as this is a base and the height here? Because then you're not going to get where you want to go. Alright, you've got to force it with this as a base and DB as a base. So if DB is the base, do you see that the height has to be the same thing? Will also be that H. Are you seeing this? Okay, and please remember I still have to put the construction in. I'm just trying to put it all together first for you. So that when I do that there, it's going to be half of which is going to make this happen. The base for ADE we said is going to be AD. The base for the other one is going to be BD, DB, doesn't matter what, are you with me? But what's the height for that top triangle? H. What's the height for the bottom one? Which will make what happen?
Cancel.
And what's left? You forced it to be AD over D. You are forcing this. Are you with me here? Everything is legal, but you've got to know where you're aiming. Otherwise, what do you want to do? So you did that so that you could get there. But then, where's the rest of it? So for the rest of it, to find AE over EC, you put the area of triangle ADE, again, the big triangle, over this time DEC. It's something you've got to teach yourself, because now it could be that this sketch is given to you, but it's X, Y, Z, K, M, whatever. You've got to know it's this one over that one. And then, next step, and this triangle's area over this triangle's area, DE. Why? Because you taught this. This is for 6 marks. That's the way it's done, with areas. Nobody said anything about areas, but the area is the tool that you're going to use to get to this theorem. Alright? Guys, you've got to follow, otherwise you'll be lost. So for this area then on top of each other, I'm going to need, again, half base times height. Now I know that already. Are you with me? So it's going to be half, which is going to fall away again. Okay? The base for that top one now is going to be AE. I'm forcing it. And this one's going to be EC. But what's the height? And therefore I'll need another construction. The height there would be coming from D. And it's, I think they called it K in the textbook. Doesn't matter if you call it M or whatever. But that height for this triangle is K. And for this one is still K. Because it's still that one that doesn't have a perpendicular height unless I've extended a little bit. That's what the pre-knowledge was for. Do you see this? That if this is my base, the height must come from there, but this is Q. I've got to go there and find the same height. So what's the both of them height?
K.
Which will fall away, and I'll be left with. But now I have to get them equal. Because there's no reason to say that they equal yet. And to get to them being equal, I'm going to use this. Because now in this triangle here, these two triangles here, we are going to find that this little one and this little one are the same. But we've already got AD at the top in both of them, which obviously is the same thing. If we can prove the bottom ones are the same, then we can put these two equal to each other. That's the whole story. Okay? So we've got to make a connection between the two of them. So that's where this comes in, and we're going to say, but triangle, these little ones, BDE is equal to the triangle DEC. Now it's fine to write that. I personally like to say area, because it's about the area, but lots of people, and in the sums, it's fine if you just write the triangle is equal to the triangle. That means that the areas are the same. Okay? So I'm saying there's a connection between these two. Are you seeing that this is exactly the same?
Yes.
What is the same of this? There's a reason why they're the same, because of this theorem. And if this is the same thing and this is equal, then these should be equal to each other, making those two equal to each other. Then I'm done. But you've got to see those connections. So why is BDE and DEC equal to each other?
Same base.
Same base,
Same.
same parallel lines. Theorem that you're actually supposed to do in grade 10. That if they have the same, well, it's actually just knowing the formula. Same base, same height, will have half base times height being the same. Happy with that? So now let's get them together. So now my next step would be to say, but then in other words, ADE over BDE will be the same as ADE over DE. See, it's just a lot of writing. But are you following here? I've made a statement, I made another statement. Now I'm bringing them together saying, because these pieces are the same, I can put those equal to each other with no reason, because it's logical. If those are the same, and those is exactly the same thing, then they've got to equal each other. This we establish is equal to AD over DB. This we've established is done. That's how it works. With crucial, you will get 0 for this perfect sum if you didn't tell me what your construction was. Okay. I wouldn't have given you 0 because it's already on the sketch, and that they do allow. If everything is on the sketch, but please don't push your luck. Write down your construction. Now, what do we write? Now, there's no specific way that you have to write it, but you did join D and C, or you can even just say draw DC. Are you with me here? And DE. Then those construction lines are drawn so that I can talk about D, E, B, etc. And what else did I also construct? The heights. So maybe a very good thing, A, B, C, D, E, F, G, to say I'm drawing FE. Perpendicular to A, B. Or you can say it in words. From E, draw a height perpendicular to A, B. That was much faster. Also, what did I do? I drew this. I drew DG perpendicular to AC. Are you with me, everybody? There's not a perfect way to write this, as easy as you can. You've got to tell me that you drew those two green lines and those two heights, which we called H and K, so that here we could see them falling away, the H and the K. Are you with me, everybody? It's not going to just jump into your head one shot. You're going to have to practice this a few times before you're going to get it. But once you know how it works, then it's fine. Because I'm telling you now to try and go and memorize this, not knowing what's happening here, it's not going to work. And they look exactly. You can't get confused somewhere here, leave out stuff, you're not going to get marks, because it has to logically follow on each other. So it can be very confusing for the first time that you see it, but remember, practice makes
It's perfect.
okay. So if you've done it like 3, 4, 5 times and you got it, then just before the June exam and just before the prelims, etc., you're going to take half an hour or an hour again just to get through your theorems. And then it's going to go quick. But you can't leave this until the day before you write. You're not going to get this just like that. Okay? So, first of all, and where does the 7 marks come from? Definitely a mark for the construction. Like I said, either it's going to be on the sketch that I can see it, but please write down construction. That's a mark. None of that, 0. This can be perfect, then I know you memorized it, but you don't get one single mark if you didn't show or write the construction. That's the rule. So for all 6 of your theorems, if at least you know the construction and you write that down, you've got 1 out of 5 or 6 marks, for sure. Okay. So you've got to learn, just like you knew that with line from the center of the circle perpendicular to a chord. What's the method? Do a construction. Do congruency. How do I just know that? Practice makes progress, right? Same with this one. How do we do this one? There's a whole lot of constructions and we're working with area over area, area over area. That's the method that you must memorize. Because you cannot memorize this AB over DE. Because then I change it and it's not ABC, it's ABC and then you're done. Are you with me? Okay. Theorem number 2, the last formal proof that you've got to study for your final exam. One of the 6 is going to be asked is the one that says if you have 2 similar triangles, so they can give it to you and say triangle ABC is similar to to triangle DEF. They've got to give it to you. That indicates what? If they are similar,
Angles are the
they
same.
have the same angles. So it's something like dot there, crossy here, hashtag there. Are you with me?
Yes, ma'am.
That's been given because it's similar. Now to prove the theorem that says if it's similar, now guys you know this, we've done a few sums already, that says that AB over DE would be the same as
BC
BC
over
over
EF.
EF would be the same as.
AC over DF.
Okay, now that's the question. But now I know that, yes, we're now proving the theorem, just like with all of them. Okay. So, to prove it, what's going to be your first thing? Construction, there's going to be a construction. There's always some study there. You know that you're using congruency, or you know that you're using angles at the centers twice the angle of the circumference, or you know that you're using areas of triangles. For this one, what you're going to be using is congruency. How can anything be congruent here? You're going to make two triangles congruent. You're going to take the smaller one, and actually what you're doing is you're copying it here. But then you can't just do that. Yes, we're going to say the following. That angle is the same, right? We're going to make this be the same as that one. So in other words, measure it. Come here, measure it. Also measure that one that was whatever over there. How do you do that? You construct it. You make sure it is. Now what can you tell me about those two triangles then? They are?
Same.
Same. Congruent. Not similar. Congruent. This purple one and this red one will be exactly the same because you're making it with your construction. So I'm going to say construction, we are measuring with the same word as you got, G and H. They make it a G and a H, I'm also going to make it a G and a H. So what's our construction? We're doing AG the same length as DE. We make sure it's the same. We're making AH the same as DF. We're making it the same. What's going to happen then? And that's it. That's the construction. It's not as bad as the previous one. Now, there's going to be three parts of this whole proof. First part is going to be the congruency. You're going to say in triangle AGH and triangle DEF. Look familiar? Because that's the way that you do congruency. And the reason must be side, 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 angle, side, or right angle side, which is not this case. What is the reason?
It's side.
Two sides included angle, so it's going to be side, angle, side. Now we're going to write that. So why is A equal to D? Because it was given that the two triangles are similar, so that's given. Because the triangles are similar. Then we've got those GH, or AG and DE, and AH and DF. I made them the same, so what's my reason? Construction. Please don't do what I've just done there. Write it up, construction. So the reason for congruency would be side angle, side. So it's going to be AGH and DE. Now, man hasn't told you where we're going yet. I'm just saying first part, you make them congruent. So that's the first part. Then we're using that congruency. Never ever do we ever write down congruency and not say from congruency. We do the congruency to get something. So in other words, now the rest of the sum is going to follow like this. I'm going to say that this little star here will make a little star here. Why? Because they are now twins. So this one will also be a little star. So you can make a G1 if you want to call it AGH. So AGH would be the same as E, right? From congruency. That's why it's also a little star. But what does that tell me?
They're the same. They're the same.
They're the same, so what?
So,
The
so G
They are corresponding. So,
similar.
which brings me to theorem. Remember how Euclidean geometry works? The first theorem brings you to the second one, the first few to the sixth and seventh one. This first one is now appearing. I've made it appear by putting that line in there, doing the congruency. The first part is the congruency. The second part is to prove parallel lines so that we can use theorem. Right, this is just my notes, so you can hear. So from congruency, we got those two equal to each other. Now I'm going to say, okay, in other words, G1 is the same as B. And that is why the lines are, because they are corresponding. And then I can use theorem 1. So, okay, so the lines are GH and B. C, and my reason why they're parallel, because of? Because corresponding angles are equal, the lines are parallel. If lines are parallel, the corresponding angles are equal. So now that I have it, I can use theorem 1. Saying what? In this triangle, I will have a G over a B. Any of them are working, but remember, I'm forcing this. I would like it to be A, B over D, E. Look at me forcing it. I would like it to be A, B over D, E. But D, E will be the same as AG. So I'm going to say A, B over AG. A, B over AG. A B over AG would be the same as whole 1 over the top one. Whole 1
Over
over the top one would be AC over A.
H
Reason? Theorem 1. What is it?
was
Line parallel to one side of a triangle will do what?
divided proportionally.
Divide the other two sides proportionally. That's theorem 1. But then we are substituting the AG with DE because they are the same. And we substitute the AH with DF, which gives me this one. Are you with me, everybody?
Yes, ma'am.
AB over AG is then DE, and AH is DF. Do I have to give a reason for that?
No.
Because I'm substituting like or equal parts. And now I'm done, but not quite done. This would be full marks for the exam. But where's the last bit? So all that the rest of the theorem says is, likewise, if you do what? If you don't draw your line there, but you draw it here, you'll get those connections and those connections which you would like there over there. So you can just say, likewise, you can find BC over EF also equal to the rest of them. That's all you need to say, and you don't even have to say that. If you stop there, it's fine for them. Alright, so BC over EF would be the same as the AB, DE, and AC over DF. So actually what you should do is do the whole thing over again. Drawing the line like that, saying there's the triangle that's going to be congruent to that one, getting your lines parallel, doing the same exact thing, and that's why it's a likewise sum. Only if it's exactly alike can you ever write likewise.
Okay.
Like I said, if you stop there,
It's okay.
that would be a perfect theorem proof. Okay.